there's a deep relationship between functions and iterators. And that is captured in Python by what are called generator functions. So, as a function gets evaluated, its body is executed and different values are created along the way. In a generator function, those intermediate values that are created can be yielded so that they can be processed as a sequence. And that creates an iterator over multiple values. So generator functions are special because instead of just returning one value, they can yield many values in order, and then the function that calls them can access each of these values in turn. So here's the story of generators and generator functions. A generator is an iterator. So it's a special type of iterator that's backed by a generator function. A generator function is something you can recognize because it uses the keyword yield to yield multiple values. Now, this is different from return, although it behaves in a similar way, because return stops the execution of the body of the function forever, whereas yield just provides some value, but then the body of the function keeps getting executed, perhaps yielding again. So when a generator function is called, it returns a generator, which means this is something that has a next method that can be used to access each value that's yielded by the generator function in turn. So here's an example. I'm going to define the same iterator over letters that I had before, but using a generator function by saying I'll start out with some next letter and then the end, and while next letter is less than the end, I'll yield that next letter. And then I'll change next letter to be rebound to the letter that's one after whatever next letter was before in the ASCII sequence. So A will be followed by B, etc. Now what happens when I call letters generator on two arguments A and E is that next letter is bound to A, end is bound to E in a new frame. And what you get back here is an iterator which lets you walk through all of the different letters that are yielded by the letters generator. So letters generator doesn't return anything. Instead it yields values, which means it gives you back an iterator which can access all of the values that are yielded, not just the first one. So if I print each letter, then I'll get A, B, C, D, and then when I reach to the bottom of the body of this function, that means I raise stop iteration and I'm finished with the for statement. So let's quickly type this in. This is an independent example of everything that I've done so far. It's a letters generator function which takes in some next letter that it's going to start with and the end. And while it's the case that the next letter is less than the end, then we'll yield the next letter. So that says return this value but keep going because I'm going to return other values later as well. Okay, I rebind next letter to B. What I get when I form a character out of the ASCII number corresponding to letter plus 1. And that's it. So this says execute the body, yield as many times as you yield. And when you're done, you've reached the end of the iteration. So let's see exactly what happens when I call letters generator on A through E. So S is a generator object. S is something that I can call next on to get A, and then to get B, and then to get C, and then to get D, and then reach stop iteration. Which means that I can use this in a for statement. And it will print all the letters of the alphabet. So that's a simple example of a generator. Let's do some more examples. So what examples shall we do? Well, let's generate Fibonacci numbers. Okay, So here's a fib generator, which will yield the first Fibonacci number 0, and then we want to keep around the previous and the current, which starts out as 0 and 1. And then what are we going to do? Well, forever, there are infinitely many Fibonacci numbers. We will yield the current one, and then we'll rebind previous and current to be equal to the current one and the sum of the previous and the current. So what have I done? I've written a while loop that runs forever, but notice that it only yields occasionally. And therefore, when I create a Fibonacci iterator by calling the fib generator function, fibiter is a generator object that was constructed immediately. And the next Fibonacci number, since we haven't asked for any yet, is 0, and then 1, and then 1, and then 2, and then 3, and then 5, and then 8, and then 13, and then 21, and then 34, etc. All the Fibonacci numbers. So notice that this while loop doesn't just run forever. Instead, it runs until it yields. And it waits there, remembering exactly what was the state of the environment for this fib generator when it yielded, and it only continues until the next yield when somebody asks for the next element. What's another example? Well, how about all pairs of elements from some iterable S? So how do we get all pairs of elements that are an element from S and another element from S? Well, how about for X in S and for Y in S, yield the pair X comma Y. Now what is this going to do? If I get all pairs for 1, 2, 3, then it should give me a generator object, and if I list the contents of that generator object, then I will get all the pairs that are some element in 1, 2, 3, and then another element in 1, 2, 3, of which there are 9 pairs. Let's define the letters class using a generator to define the iter method that returns iterators. So here's another definition of letters, which, as before, takes a start and an end, instead of using the letter iter class in order to define iter, I'll just define a generator function here. And this is a very common pattern for iterating through the elements in an implicit sequence represented as a class. Oops, this is a class. Okay, so in this class, what we're going to do is set the next letter to be start. And then while it's the case that the next letter is less than self.end, we will yield that next letter. And then we'll update next letter to be the character that is one more than the current next letter. So how's this different from before? Well, now when I create some letters, let's say from A to E, I've created a letters object from which I can get iterators. Now the iterator will walk through the letters from A through E, but it will do it using a generator object created from this function. So if, for instance, I want to list all pairs of letters in S, actually let's print them out. For pair in all pairs of S, print pair, then what I'll get is all the different pairs of letters that was created by having an iterator generated every time I entered this for statement, another iterator every time we have this for statement, and then walking through all those letters to create all these different pairs. How about one last example the power set of T yields all subsets of iterator T. So iterator T is going to represent some sequence that we walk through, and we want to have all subsets of that. So Powerset is going to be a generator function. What it does is it tries to get the first element. For every rest in the power set of T, we will yield the rest without the first element, and we will yield the first element followed by the rest. And what happens if we reach the end of T? That's stop iteration. We should just yield the empty list, which is the power set of the empty iterator is just the empty list. If you don't know what a power set is, that's all the subsets of T. Let's see how this works right now. We'll start out with a list. S is 1, 2, 3, 4. Iter S is some list iterator, and if I pass that iterator into Powerset, then I'll get a generator object, and if for every subset M in that Powerset I print it out, then I should get the empty set, so that's a subset of 1, 2, 3, 4, and then the set 1, and then 2, and then 1, 2, and then 3, all the way up. This is every possible subset of 1, 2, 3, 4, which I get by yielding the subsets themselves of everything that's left after I pull out the first element, or by yielding that with the first element included in the front.